Okay, chapter 3. I personally think chapter 3 is the hardest, so I apologize if I don't do a perfect job. So when describing a graph, you're going to use direction, form, and strength. So direction is if it's negative or positive, form is if it's linear or not linear, and then strength is basically, you can say things like moderately strong, moderately weak, very strong, very weak. So that's just some examples. I'm going to go ahead and do the example for that. So describe this graph. For direction, it's going to be negative, as you can see, because the points are going down. Form, it's linear because it's a line. And then strength, I would say that it is very strong because it follows the line. So I'll just put strong. Okay, then we talk about variables here. So basically, to sum up response and explanatory, response is what happens after. So it's like, say you're doing, I don't know. Okay, so it happens due to this variable. And then this is just a little picture of a scatter plot in case you forgot. So correlation, which is R, that's going to be, so R is in between 1 and -1. So the closer it is to 0, the worse it's going to be. So 1 and -1 are very strong. And it measures direction and strength. So you can do it on your calculator, and it must be quantitative data. So let me see if I actually have an example of that. Okay, I can do an example of that later. And then another page of chapter 2. Regression line. This is said y hat equals a plus bx. You can also find this on your calculator, and y is the predictive value. Residuals, you can find that on your calculator. Residual is the observed minus the expected. So when you're finding the residual plot on your calculator, it shouldn't make sense. There shouldn't be a line. If there's a line, then you have an issue. It should be completely random. And I will show you that on during the example time. Least squares regression line, that's going to read as R2. And that's basically the grade of the line. So the higher it is, the better your line is. So say you have a 0.83 line. That's going to be pretty good, because that would be, like, say, that would be a B if you did it in our grade terms. So it would be an 83%. But say you have like a 0.1, that's going to be a really bad grade for the line. So the squared regressions line is just the grade. So that's it for the notes. Then I'll move on to the examples. So now I'm going to do this example down here. So find R and R2, which is the least squares regression line, and the residual plot. So I already put it in my stat plot, these numbers. So as you can see here, and then to find the R and R2, you're going to go to stat, and then, or second, you're going to go to stat, calc, and then it's going to be the 8th one down. So I'm just going to click 8, enter, 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 and then your R is 0.83, and your R2 is 0.7. So as you can see, the grade for this line isn't the best, but it's also not terrible. And that's the correlation, 0.83. So I'm going to go ahead and show you what this looks like. So I'm going to go zoom 9, and that's that. So now I'm going to show you how to do the residual plot. You're going to go to second, y equals. You're going to click on stat 1 on, and then you're going to go down to y list. You can go to second stat, and then it's going to be the last one down there. So you're going to click residual, and then you're good there. So second quick, and then I just go ahead and do zoom 9 so you can see that. And as you can see, there's no line, so this graph checks out.